The next algorithm that we will be learning is called bubble sort. Bubble sort is one of a few very well-known sorting algorithms, and it is widely used as a technical interview question in the job market. Our bubble sort algorithm will take in one parameter, an array of numbers, and it will return that array of numbers sorted from least to greatest. Now, there are multiple different ways to get the end result of a sorted array, but bubble sort is implemented in a specific way. That is what makes it bubble sort. Let's look at a sample array and go over an example of how bubble sort works. We will use an array that contains the numbers 5, 3, 8, 2, 1, and 4. Bubble sort works by starting at the beginning of the array and looping through the whole thing. As we loop through the array, we compare each number with its neighbor to the right. So in this case, we would start at the first number, 5, and compare it with 3. Then we would compare 3 and 8, then 8 and 2, then 2 and 1, and so on. As we compare each number, we check to make sure that they are in the correct order. If they are not in the correct order, we switch them. And we do this the whole way through our array. So for our example case, our first comparison would be 5 and 3. Since 3 is less than 5, we need to switch these two. So that is what we do. Then we move on to the next pair, which is now 5 and 8. Since 5 is less than 8, these two are in the correct order, so we don't switch them. Next, we compare 8 and 2, and we switch them because 2 is less than 8. Then we compare 8 and 1, and we switch them. Then we compare 8 and 4, and switch them. That completes our first pass through our array. And as you can tell, our largest number is in the correct place, at the end of the array. This is why it is called bubble sort, because the larger numbers essentially bubble up to the top of the array. Great. So now we have gone through our array one time. Now we simply do the same thing again to further sort our array. So we will start by comparing 3 and 5, and we leave them as they are because they are in the correct order. Then we compare 5 and 2 and switch them because 2 is less than 5. Then we compare 5 and 1 and switch them. Then 5 and 4 and switch them. And now we are down to the final comparison for this loop. We actually do not need to compare 5 and 8 because we know that our largest number bubbled up to the top of our array on our first pass through. So there is no way any other number could be greater than it. So we can stop right here on this pass through and not make this last comparison. Now the largest two numbers are in the correct place in the array. Cool. Now we can start our next pass through the array and sort it even further. We compare 3 and 2 and switch them. Then we compare 3 and 1 and switch them. We compare 3 and 4 and leave them as they are. And now we can stop at this point because since we have already done 2 passes through the array, this one being our third pass, we know that the top 2 elements in our array are already in the correct order, so there is no point in going any further. So our current loop can end here. Now, after completing 3 full loops, we know that the top 3 elements in our array are definitely in the correct order. Our fourth element from the top, 3, also happens to be in the correct order, but this is just by chance, so we can't assume that that element is correct until our next pass through is complete. So from this point, we just keep doing the same thing we have been until the array is completely sorted. So we can see that it takes a lot of passes through our array to make sure that it is fully sorted. But how many passes does it take? The answer is that it takes the length of the array minus 1 passes to fully sort our array. Or in this case, it would take 6 minus 1, or 5 passes through the array to fully sort it. And that is it. That is how our bubble sort algorithm will function. We loop through our array.length, minus 1 times, comparing each pair of numbers as we go, and switching them if necessary. On each pass through the array, we stop one element shorter than the previous pass, because we know that the larger numbers have already been bubbled up to the top on the previous passes, so there is no need to sort them again. At the end of all this, we have a sorted array done by bubble sort. I encourage you to try and build out this algorithm on your own before moving on to the next video, where we will work through a solution for it. Good luck, and see you in the next video.